So in the first segment of this lesson, we looked at points of discontinuity, and we were talking about two kinds of points of discontinuity that existed. We had the vertical asymptote, and we had the hole in the graph. This lesson is going to focus on not the vertical asymptotes, but the horizontal asymptotes instead. So we're going to be looking at where graphs tend to level off to. And the first thing I'm going to have you guys write down for this portion of the lesson is exactly what I just finished saying. The definition of a horizontal asymptote, which is where the y value of your graph is going to level out to on the very far sides of the graph. So when you get really, really big or really, really negative on your graph, where is it going to level out? And let's go ahead and investigate that by looking at some graphs just like last time. So the first graph right here is an example of one we would have done in the previous lesson back in like 6-4. When you have a simple rational equation like what you guys see right here, all you're going to do is look at where it moves up and down, and that's going to end up being your answer. So if we have a down 5, we can see that indeed there does appear to be an asymptote horizontally, where I am putting my cursor right now at y equals -5. If I zoom way out of my graph, I lose sight of what's going on, but if I go just sort of far, you can see that indeed -5 is where the graph goes flat. So that is a pretty easy indicator of where your asymptote is going to be. It's just the up and down number when you have a basic graph like we did last time. Now, let's get into more complicated, more interesting graphs like this one right here you guys see for the second picture. This graph has 3 pieces going on, and if I zoom in a little bit, it appears that my graph actually levels out at 0 horizontally, both on the right and the left side. I'm going to zoom out for a second so you guys can see it does look like it's 0 along there on the left, 0 on the right as well. But I want to show you kind of an interesting clarification here in the middle of my picture. When you have a horizontal asymptote like this, it is actually possible for your graph to hit that value before we get to the ends of the graph. Look right here at this dot. This graph actually hits at -3, 0. A horizontal asymptote is more like a guideline for what's going to happen on the ends of a picture. In the middle of the picture, you very well could hit that value, or you can even hit it on the edges as you're working towards that value at the ends. A vertical asymptote. Last time, what we talked about, you can never, ever, ever have a graph that goes right through a vertical asymptote. They're like force fields that you can't cross over, but a horizontal asymptote is more of a guideline. And I have that written down as a little note on this next slide. You can never, ever, ever plow through a vertical asymptote, but a horizontal asymptote you can hit as long as it's like you can work towards in the ends, and that's not too big of a deal. All right, so with that out of the way, we are going to go ahead and look at 3 different situations for where my horizontal asymptote is going to be. And I'm going to get to that in my examples. This first example right here that I have highlighted leveled out at y equals 0 on the very ends of the graph. The right side and the left side both leveled out at 0. I'm going to look at this next example as well. Crazy looking picture right here, but it again appears like there's a little wobble right here. But if you go to the ends of this graph, it also is going to level out at 0. If you have a fraction where the bottom is bigger or stronger than the top, remember earlier in the year when we talked about end behavior, we talked about which part of the fraction or which part is stronger overall. If the bottom of your fraction is stronger or has a higher power, what's going to happen if you have a fraction with a small numerator and a large denominator? It's going to level out at 0 because the bottom, small number divided by big number, gets you a decimal, eventually gets you 0. So situation 1, like we've seen in our first couple pictures, if the degree on the bottom is bigger, so that means that your power on the bottom is bigger, like third power versus second, your graph will level out at 0. This is assuming we're not adding or subtracting anything on the ends. If I tacked like a +4 on the end of this picture right here, it would scoot the whole thing up to 4. But assuming we're not translating, if the power on the bottom is bigger, your graph will always level out at 0. Okay, so that is the first situation. Make sure you get that all copied down. I have a little list in your notes with the 3 situations. Give an example, write down what I have, and draw a quick sketch of what that picture looks like. All right. So the second situation is when the power on the top is bigger. So for this next graph I have highlighted right here, I just reversed the one we had. And as a reminder, here's what it looked like. It leveled out at 0 when the bottom was bigger. If I took that same picture and I flipped it around, totally different looking picture. There's no real similarity in these two graphs when they've been flipped over. But let's look for a second at where this graph in green appears to level out. As I zoom out and zoom out and zoom out and zoom out, this graph doesn't go flat ever. It just keeps on going up. If we were doing end behavior, as x approaches infinity, f of x approaches infinity as well. It just keeps on going up like a polynomial graph. So this graph actually doesn't have a horizontal asymptote at all. It just keeps on going up. If you look at this picture, this is something a little beyond algebra 2. It's more pre-calc territory. This graph actually has a diagonal asymptote called a slant asymptote or an oblique asymptote. That is something that I'm not going to worry about right now with you guys, but there are diagonal asymptotes just like there are horizontal and vertical. That's more pre-calc territory. So anyway, that picture doesn't have a horizontal asymptote. I have another example where the power on the top is bigger right here, x squared versus x. And if you graph this guy, once again, there appears to be a diagonal asymptote. That happens when the power on the top is 1 more than the denominator. That doesn't really matter. So it's not like there's always going to be a diagonal asymptote. But what we care about in this video is where does it go flat? It never ever does. This picture will not go flat, does not have a horizontal asymptote. If you have a fraction with a giant numerator and a smaller denominator, big number divided by small number doesn't have a limit to how big it gets. It just keeps on getting bigger when you increase. So situation 2 is when the degree on the top is bigger than the degree on the bottom, and the graph does not have a horizontal asymptote. It just keeps on going up or just keeps on going down in that case. So that is situation 2. The final situation we have to talk about is what happens if they're the same power on the top and the bottom of your fraction, like you see on this next example down below. So if I graph this guy, x squared on top, x squared on the bottom, at first glance, I'm kind of zoomed out right now. It's hard to see. It levels off somewhere. And if I look at this picture, it looks like it's going to level out. Like it's kind of doing a weird little thing right here. But if I keep on following this picture over, and I keep on going, and I keep on going, eventually this picture is going to level out at positive 1 on this side. So if we look right here and keep on going, it's eventually leveling out at positive 1. Same thing on the left side of the picture. If you look at what's going on here, I'm at like 2 right now, 1 point something. If I go far enough along, it will level out at a positive 1 on both sides. How did positive 1 end up working out? Why isn't it 0 right here? Well, if you have a situation where they're the same power, one isn't going to super overpower the other, like in the first 2 scenarios I talked about. Instead, what happens is actually to break the tie, because they kind of tied top and bottom for which power is bigger, you end up looking at the leading coefficients, the numbers in the front. And I just added on that equation, there's a 1 up top and a 1 on the bottom. 1 divided by 1 means that graph levels out at 1, y equals 1. I have one final example in this video, and I'll tab back over to the notes. This time I have a 4x squared up top and x squared on the bottom. First of all, if you look at this picture doesn't have a single vertical asymptotes. The reason there's no vertical asymptote on this picture is if you solve this bottom part, the solutions are imaginary. So there aren't going to be any vertical asymptotes that appear because there's no real number that would make you divide by 0. That's not important for right now, though, because what I care about is where my horizontal asymptote is going to go. And if you look at this picture, it will eventually level out at 4 on the left and on the right. I'm at like 3.7 right now. And the way that they got 4 for this picture is by taking 4 divided by 1. If the powers are the same, you break the tie by dividing your leading coefficients. So this graph levels out at 4. But even though it levels out at 4, I want to point out again, I actually hit 4 somewhere like right there where I have my cursor now. A horizontal asymptote talks about the ends of the graph. It doesn't say anything about what happens in the middle of my picture. So my third and final scenario, if you have the same power at top and bottom, you divide your leading coefficients, and that's how you figure out your horizontal asymptote. So when you have fractions with variables, those are the 3 scenarios you have to be able to look out for to decide where your graph will level out.